Let's move to the question number 8. A geometric progression is such that its second term is negative 120 and its sum to infinity is 160. Part A, find the common ratio. Means we need to find the common ratio. Where second term is given, which is A2, and this one is equal to negative 120. And the sum to infinity is 160. It means sum to infinity is 160. This is a geometric progression. It means we have the geometric progression which is equals to the A, then AR, then AR is square, and it moves on up to AN, and this AN is equals to the AR to the power of n minus 1. This is a second term. AR is a second term which is given. So we can say that second term AR is equals to the negative 120. Secondly, we have been given sum to infinity, and we know that sum to infinity is equals to A over 1 minus R, and this one is equals to 160. So solving this equation, we will have A is equals to 160 times 1 minus R. This is the equation 2, and this one is equation 1. We need to find the value of common ratio. So we have two equations. So by using these two equations and solving them simultaneously, we can find the value of R. So from here, A is equals to negative 120 over R, and plug in equation 2 to find the value of R. Okay. So this equation 2 will be equals to the negative 120 over R is equals to 160 times 1 minus R. This one is 3 and this one is 4. By cross multiplying, we will have 4R times 1 minus R is equals to negative 3. Further solving, we will have 4R minus 4R square is equals to negative 3, and this one is equals to 4R square minus 4R minus 3 equal to 0. This is the quadratic equation, and this quadratic equation can be solved by factorization. For example, negative 3 times 4 is equals to negative 12, and negative 6 times 2 is also equals to negative 12, and when we add negative 6 and 2, we get negative 4. We can use these calculations to factorize this quadratic equation. So this equation is equals to the 4R square minus 6R plus 2R minus 3 equal to 0. Taking 2R common from first two terms, so we will have 2R times 2R minus 3. Taking negative 1 common, we will have 2R minus 3. Sorry, positive 1. This one is positive, equal to 0. Further solving, we will have two factor which is 2R plus 1 times 2R minus 3 equal to 0. Equating each factor with 0, we will have 2R plus 1 equal to 0, and in this case R is equal to negative 1 over 2. On the other side, 2R minus 3 equal to 0, so R is equal to 3 over 2, which is equal to 1.5. We have two values of R. Which one is applicable? You can see that sum to infinity is equals to the 160, and we know that sum to infinity is equals to A over R, given that absolute value of R should be less than 1, and in this case R is greater than 1, so we will ignore it. So we can say that applicable value of R is equals to negative 1 over 2. Now part B, the first 9 terms of the progression are now removed. It means the first term will be A10 from this progression. This is the first term. Because first 9 terms has been removed. Find the sum to infinity of the remaining term. So we need to find the sum to infinity by applying formula which is A over 1 minus R. And in this case, first term will be the A10. So first we find the 10th term from the part A. So we know that 10th term A10 is equals to the AR to the power of n minus 1, means 10 minus 1, and this one is equals to AR to the power of 9. and we just calculated the ratio which is equal to negative 1 over 2. Okay, to find the 10th term we also need the value of a, and a can be find out by using the equation 1 if we plug value of r in this equation. So from equation 1 we know that ar is equal to negative 120, and we just calculated the value of r, so plug r is equal to negative 1 over 2 in this equation. We will have a time negative 1 over 2 is equal to negative 120, and in this case a is equal to 240. So when we plug value of r and a in this equation to find the 10th term, so a10 is equals to a, which is 240, times r, which is negative 1 over 2 whole power 9. So we will have 240 over 2 to the power of 2 times 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 2 to the power of negative 2. When we solve this one, we will have 60. When we cancel this one, 4, so this one will be equal to 15. So we will have 15 over negative 32. So this one is 10 term, which is equals to negative 15 over 32, which is first term for part B, because first 9 term has been removed. So we have the first term, which is negative 15 over 32. Now second term will be AR. This one is A. So AR is negative 15 over 32 times R, which is same. R is same for both cases. So negative 1 over 2. And then negative 15 over 32 times negative 1 over 2 square, and move up to infinity terms. We need to find the sum to infinity of this progression. So this progression has sum to infinity, which is equals to a over 1 minus r, and in this case a is equals to negative 15 over 32 and r is equals to negative 1 over 2. So plugging, we will have a, which is negative 15 over 32 over 1 minus r, means negative 1 over 2. So further solving, we will have negative 15 over 32 over 2 will be LCM, so 2 plus 1 over 2. So further solving, we will have negative 15 times 2 over 3 times 32. So this one is 16 and this one is 5, and this one will be cancelled out. So we will have sum to infinity is equals to negative 5 over 16.